Let's talk about the use of confirmatory perspective. The most direct method of validation, the result is more to a confirmatory perspective and assess the applicability of the result either with a split sample in the original data set or with a separate sample. The comparison of two or more factor model result has always been problematic. However, several options exist for making an objective comparison. The emergence of confirmatory factor analysis through the structure equation modeling has provided one option, but it is generally more complicated and required additional software packages such as LIS, REL, and EQS. Apart from confirmatory factor analysis, several other methods have been proposed ranging from a sample matching index to program FMATCH design specially to assess the correspondence between factor matrix. The method have had sporadic use owing the part to first their perceived lack of sophistication and second the unavailability of software or analytical program to automate the comparison. Those the confirmatory factor analysis is not appropriate, this method provides some objective basis for comparison. Let's talk about the assessing factor structure stability. Another aspect of generalizability is the stability of the factor model's result. Factor stability is primarily depends on the sample size and on the number of cases per variable. The researcher is always encouraged to obtain the largest sample possible and develop Parasomnian model to increase the case to variable ratio. If sample size permit, the researcher may wish to remedy split the sample into two subsets and estimate the factor model for each subset. Comparison of two resulting factor matrix will provide an assessment of the robustness of solution across the sample. Let's talk about the deducting influential observation. In addition to generalizability, another issue of importance to the validity of the factor analysis is the de- detection of the influential observation. The researcher is encouraged to estimate the model with and without observation identify as outlier to assess their impact on the result. If omission of the outlier is just the result should have greater generalizability. Also, several measures of influential that reflect one observation position re- relatively to all others. For example, covariance ratio are applicable for factor analysis as well as finally the complexity of the method proposed for identifying influential observations specified to factor analysis limit the application of this method. Let's talk about the stage 7, that is additional use of factor analysis results. Depending upon the objective for applying factor analysis, the research may stop with factor interpretation or further engagement in one of the method for data reduction. The objective is simply to identify logical combination of variable and better understanding interrelationship among the variables. Then factor interpretation will suffice if provides an empirical basis for judging the structure of the variable and the impact of their structure within interpretation the result for other multivariate technique. If the objective however is to identify appropriate variable for subsequent application to other statistical technique, then some of the factor reduction will be employed. The two options include the following. First is selecting the variable with the highest factor loading as a surrogate representative for a particular factor dimension, replacing the original set of variable with an entirely new smaller set of variable created either for summit scale or factor score. Either option will provide new variable for us, for example, as the independent variable in a regression or discriminant analysis, a dependent variable in multivariate analysis of variance, or even as The clustering variable in cluster analysis, we discuss each of these options for data reduction in the following section. Selecting surrogate variable for subsequent analysis. If the researcher objective is simply to identify appropriate variable for subsequent application with other statistical technique, the researcher has the option of examining the factor matrix and selecting the variable with the highest factor loading on each factor to act as a surrogate variable that is representative of that factor. This approach is simply and direct only when one variable has factor loading that is substantially higher than all other factor loading. In May instance, however, the selection process is more difficult because two or more variables have loading that are significant and fairly close to each other, yet only one is chosen as representative of a particular dimension. This decision should be based on the researcher a prior knowledge of theory that may suggest that one variable more than the other would logically be representative of the dimension. Also, the researcher may have knowledge suggesting that a variable with a loading slightly lower is in the in fact more reliable than the highest loading variable. In such cases, the researcher may choose the variable that is loading slightly lower as the best variable to represent a particular factor. The approach of selecting a single surrogate variable as representative of the factor, although simple and maintaining the original variable, has several potential disadvantages. It does not address the issue of measurement error encountered when using the single measurement. See the following section for as a more detailed discussion. It also runs the risk of potentially misleading result by selecting only a single variable to represent a perhaps more complex result. For example, assume that variable representing price, competitiveness, product quality and value were all found to load highly on a single factor. The selection of any one of these separate variables would create substantially different interpretation in any subsequent analysis. Yet all three may be closely related as to make any definition distinction impossible. In instance where several high loading complicated the selection of the several variables, the researcher may have no choice but to employ factor analysis as the basic for calculating a summate scale or factor score instead of the surrogate variable. The objective, just as the case of selecting a single variable, is to best represent the basic nature of the factor or component, creating summate scale. Recall the concept of a summate scale, which are formed by combination several individual variables into a single composition measurement. In simple terms, all of the variables loading highly on a factor are combined, and the total or more commonly the average score of the variable is used as a replacement variable. A summate scale provides to specify benefit. Let's talk about the first benefit of the summit scale, that is it's provide means of overcoming to some extent the measurement error inherent in all the measurement variable. Measurement error is the degree to which the observed value are not representative of the actual value to any number of reasons, ranging from actual error, for example data entry errors, to the inability of individual to accurately provide information. The impact of measurement error is to partially mark any relationship, for example, correlation or comparison of group means, and make the estimation of multivariate model more difficult. The summit scale reduce measurement error by using multiple indicators variable to the reduce the reliance on a single represent respectively. By using the average or typical responses to a set of related variables, the measurement error that might occur in the single question will be reduced. Second benefit of the summit scale, that is the ability to represent the multiple aspect of the concept in a single measurement. Many times we employed more variable in our multivariate model in an attempt to represent the many facts of the concept that we knows is quite complex, but in doing so We compli- we uh, we complicated the interpretation of the result, and because of the redundancy in the items associated with the concept, those we would like to not only to recommended the richer description of the concept by using the multiple variable, but also the maintaining parsimony in the number of variables in our multivariates model. The summit scale, when properly structured, thus combine the multiple indicators into a single measurement representing what is held in common across the set of measurement. The process of scale construction has theoretically and empirically foundations in a number of disciplines, including the psychometrics, today's psychology, and marketing. Although a complete treatment of the technique and issue involved are beyond the scope and the text, a number of excellent occur are available for further reading on this subject. Additionally, a series of complication or existing scale may be applied in a number of situations. We discuss here, however, four issues basic to the construction of any summit scale: conceptual definition, dimension, reliability, and validity. Conceptual definition. The starting point for creating any summit scale is its conceptual definition. The conceptual definition specifies the theoretical basis of the summit scale by defining the concept being represented in terms of application to the research context. In academic research, theoretical definitions are based on prior research that define the character and the nature of concept. In a managerial setting, specified concept may be defined that relates to proposed objectives such as image, value, or satisfaction. In either instance, creating a summit scale is always guided by the conceptual definition specifying the type and character of the item and are candidates to include in the scale. Content validity. In the assessment of the correspondent of the variable to be included in a summit scale and its conceptual definition. This from a validity, also known as a face validity, subjectively assess the correspondence between the individual items and the concept through the rating by expert judges. Pretest with multiple subpopulations or other means. The objective is to ensure that the selection of scale items extended past just empirical issues to also include theoretical and practical consideration. Dimensionality, an underlying assumption and essential requirement for creating a summit scale is that the items are undimensioned, meaning that they are strongly associated with each other and represent a single concept. Factor analysis play a pivotal, making an empirical assessment of the dimensionality of a set of items by determining the number of factors and the loading of each variable on the factor. The test of unidimension, it the each summit scale should consist of item loading highly on a single factor. If a summit scale is proposed to have multiple dimensions, each dimension should be reflected by a separate factor. The researcher can assess the unidimensionality with either the exploratory factor analysis and the discussed in this chapter or confirmatory factor analysis. Let's talk about the reliability. What is a reliability? Reliability is an assessment of the degree of consistency between the multiple measurement of a variable. One from a reliability t-test retest by which consistency is measured by the responses for an individual at 2 points time. The objective is to ensure that responses are not too varied across time periods so that the measurement taken at any points in time is reliable. A second and more commonly used measurement of reliability is internal consistency with applied to the consistency among the variable is a summit scale. The rationale for internal consistency is that the individual items on factors and the scale should all be measuring the same construct and those the highly intercorrelated, because no single item is a perfect measurement of the concept. We must rely as a series of diagnostic measurement to assess the internal consistency. Let's talk about the first measurement of consider related to the each separate items, including the items to total uh, co- collocation correlation of the items to the summit scale score and the inter item correlation among the items. Rule of the thumb suggests that the item to total correlation exceeded 0.50 and that inter item correlation exceeded 0.30. The second type of diagnostic measurement is the reliability coefficient, which assess the consistency of the either scale. The Croback alpha, that is described in page number 15, 28, and 29, being the most widely used measurement. The generally agree upon lower limit to Croback alpha is 70, although it may decrease to 60 in exploratory research. One issue in assigning chronobatch alpha is its positive relation to the number of items in the scale, because increasingly the number of items even with the same degree of intercorrelation will increase the reliability value. Research must place more string requirements for scale with large number of items. Also available are reliability measurement derived from the confirmatory factor analysis. Including the measurement are the composite reliability and the average variable extracted. Each of the measured statistical program now has reliability assessment module or program, such that the researcher is provided with a complete analysis of both items, specify an overall reliability measurement. Any summit scale should be analyzed for reliability to ensure its appropriate attendance before the proceeding to assessment of its validity. Let's talk about the validity. Having the ensure that the scale confirmed is to be conceptual definition is undimensional and the meet the necessary level of reliability, the researcher must make a final assessment. Scale validity is the extent to which the scale set of the measurement accurately represent the concept of interest. We already described one form of validity, content of face validity, in this discussion of conceptual definition. Other forms of validity are measurement empirically by the correlation between the theoretical defined set of the variable. The three most widely accepted forms of validity are convergent, discriminal, discriminant, and nomological validity. Let's talk about the type of validity, that is convergent, discriminant, and nomological validity. The first validity is convergent validity. Assess the degree to which two measures of the same concept are correlated. Here, the researcher may look for alternative measurement of concept that correlated them with the summit scale. High correlation here indicate that scale is searching its independent concept. Let's talk about the discriminate validity. Discriminate validity is the degree to which two conceptual similar concepts are distinct. The empirical test is again the correlation among measurement, but this he summit scale is correlated with the similar but conceptually distinct measurement. Now the correlation should be low, demonstrating that the summit scale is a sufficiently different from other similar concept. Finally, nomological validity referred to the degree that the summit scale make accurate prediction and other concept in a theoretical based model. The researcher must identify theoretically supported relationship from prior research or concept principle and assess whether the scale has corresponding relationship. In summary, convergent validity confirms that the scale is correlated with the other known measurement, and the concept discriminant validity ensure that the scale is sufficiently different from other similar concept to the distinct, and the nomological validity determines whether the scale demonstrate the relationship between the exit based on theory or prior research. A number of differing methods are available for assessing the validity, ranging from the multiples multi-methods, metrics to structure equation based approaches, although beyond the scope of the exist. Numerous available sources address both the range of method available and the issues involved in the specified technique. Let's talk about the calculating the Summit scale. Calculating the Summit scale is a straightforward process whereby the item comprising the Summit scale, that is the item with high loading from the factor analysis, are named or averaged. The most common approach is to take the average or the item in that a scale which provide the researcher with complete control over the calculation and facilitate a set of using subsequent analysis. Whether variable have both positive and negative loading within the same factor, either the variable with the positive or negative loading must have their values reversed. Typically, the variable with the negative loading are reverse scored so that the correlation and the loading are now all positive within the factor. Scoring is the process by which the data value for a uh, variables are reversed so that the correlation with other variables are reversed, that is go from negative to positive. For example, on our scale of 0 to 10, we would reverse score a variable by subtracting the original value from 10, that is the reverse score 10 original value. In this way, original score of 10 and now 0 have the reverse score of 0 and 10. All the distributional characteristics are retained, only the distribution is reversed. The purpose of reverse scrolling is to prevent a cancelling out of variable with the positive and negative loading. Let us use an example of two variable with a negative correlation. We are interested in combining variable 1 variable 2 with variable 1 having a positive loading, variable 2 a negative loading. If the 10 is to top score of v1 to top score v2 would be 0. Assume two cases. In case 1, v1 has a value of 10 and v2 has a value of 0. The best case, in the second case, v1 has a value of 0 and v2 has a value of 10. The worst case, if variable 2 is not reverse scored, then the scale score calculated by the adding the two variable for both cases 1 and 2 is 10, showing no differences, where we know that case 1 is the best case and 2 is the worst. If we reverse score 2, however, the situation change. Now, case 1 has value of 10 and 10 of v1 and v2 respectively, and case 2 has value 0 and 0. The summit scale score are now 20 for case 1 and 0 for case 2, which disguised them as the best and worst situation. Let's talk about the summary. Summit scale, one of the recent development in academic research. So what is the Summit scale? That is the one of the recent development in academic research. Experienced increased application in apply and many managerial research as well. The ability of the Summit scale to portray complex concept in a single measurement while reducing measurement error makes it valuable addition on any multivariate analysis. Factor analysis provide the researcher with an empirical assessment of the interrelationship among the variable, essential in forming the conceptual of the empirical foundation of the Summit scale through the assumption of the contact validity and the scale dimensionality. Let's talk about the computing the factor scores. The third option for creating the smaller set of variable to replace the original set of the combination of the factor score. Factor score are also composite measurement of each factor computed for each subject. Conceptually, the factor score represents the degree to which each individual score high on the group of the item which high loading on the factor. Those the high value of the variable with the high loading of the factor will result in higher factor score. The one key characteristic that differentiate a factor score from a Summit scale is the factor score is a compute based on the factor loading. All of variables on the factor, whereas his summate scale is calculated by the combining only selected variables. Therefore, although the researcher is able to characterize factor by the variable with the highest loading, Consid- consideration must also be given to the loading of other variable, albeit lower, and then influence on their score. Most statistical program can easily compute factor score for each respondent by selecting the factor score option. These score are saved for us in subsequent analysis. The one disadvantage of factor score is that they not easily replicated across the studies because they are based on the factor matrix, which is described separately in each study. Replication of the same factor matrix across the studies required substantial computation program. This is the thumb rule of seven summit scale. A summit scale is only as a good as the item used to represent the construct, even though it may pass all empirical tests. That's it is unless without theoretical justification. Never create a summit scale without first assessing its unidimensionality with exploratory or confirmatory factor analysis. Once scale is deemed unidimensional, it is reliability to score as a measured by the corona batch alpha should exceed or threshold of 0.70, although a 0.60 level can be used exploratory research. The threshold should be raised by the number of items created, especially as the number of item approaches 10 or more. With reliability established validity should be assessed in term of convergent validity scale correlation with other like scale. Discriminate validity scale is sufficiently different from other scale. Non Nomological validity scale predicts orthotical suggestion. Let's talk about the selecting among the three method. To select among the three data reduction option, the researcher must make a series of decisions weighing to advantages and disadvantages of each approaches with the research objective. The guideline in rules of thumb 8 address the fundamental traits of associated with each approaches. The decision rule therefore would be as follows. The data are used only in the original sample or orthogonality must be maintained. Factor score are suitable. If generalizability of transferability is desired, then summit scale or surrogate variable and more appropriate. If the summit scale is a well constructed, valid, and reliable instrument, then it is probably the best alternative. If the summit scale is untested and exploratory with the little or no evidence, reliability or validity surrogate variable should be considered uh, if additional analysis not possible to improve the summit scale. It is a rule, thumb rule 8, that is representative factor analysis, and I have taken this. The book is Factor Analysis by written by Joseph Murphy. He is the researcher and he is the author of this book. Let's talk about the representing factor analysis in other analysis. The single surrogate variable advantage is simple to administer and interpret it. So, what is the advantage of the single surrogate variable? That is the simple and admise, administer and interpreted. This advantage does not represent all the facts of the factors prone to measurement error. Factor score. If talk about the factor score, what is the pro of the factor score? That is a represent all variables loading on the factor. Best method for complete data reduction. If we talk about the factor score are by default orthogonal and can avoid the complication caused by multicollinearity. And what are the disadvantages of the factor score? That is the interpretation more difficult because all the variable contribute through the loading, difficult to replace across the studies. Let's talk about the Summit scale. If we talk about the advantages, that is comparison between the surrogate variable and the factor score options, reduce measurement errors, represent multiple facts or the concept, easily replicated across the studies. If we talk about the disadvantages of Summit scales, that are including only the variable that load highly on the factor and excluded those having the little or marginal impact. The second disadvantages of the factor analysis, if we talk about the Summit scale, that is the no necessarily orthogonal, and third is required extensive analysis of reliable and validities issues. Let's talk about an illustrative example. In the in the proceeding sections, the major question concerning the application of factor analysis were discussed within a model building framework. To clarify these topics further, we use an illustrative example of the application of factor analysis based on data from a sample database showing the result of this is the company name and which the researcher took for uh, giving the example and clearing the concept of the factor analysis. Our discussion of the empirical example, also the lower for 6 stages models building process. The first 3 stages common for either component or the common factor analysis or discussed first. Then the stage 4 throw for if talk about the 6 4 component analysis will be the discussed along with the example of the additional use of the factor result. We concluded with the examination of the different common factor analysis in stage 4 and stage 5. Let's talk about the stage 1, that is the objective of factor analysis. Let's talk about in further. Factor analysis can identify the structure of the set of variables as well as the provide process for data reduction. In example, the perception of but on 13 attribute x6 to x18 are examined for the following reason. Understand whether the perception can be grouped. Even the relatively small number of perceptions examined here represent a complex pictures of 78 separate correlation. By grouping the presentation, HBAT will enable the see that the pictures in term of understanding its customers and what the customers think about HBAT company. Reduce the 13 variable to a smaller number. If the 13 variables can be represented in a smaller number of composite variable, then the other multivariates technique can be made more parsimonious. Of course, the approach assumes that a certain degree of underlying order exists in the data being analyzed. Either of both objective may be focused in research questions, making factor analysis application to a wide range of research questions. Moreover, as the basis of Summit scale developed, it has gained even more use in recent area. Designing a factor analysis. Understanding the structure of the perception of variable require R type factor analysis and a correlation multivariate between no respondent. All the variable are metrics and consist constitute a homogeneous of a perception of appropriate for factor analysis. The sample size in this example is an 8 is to 1 ratio of observation to variables, which falls within the except one limit. Also, the sample size of 100 provide an adequate basis for calculation the correlation between variable assumption in the factor analysis. Here is the underlying statistical assumptions influence factor analysis to the extent that the affect the derived correlation. Departure from the normal normality, homoscedasticity, and linearity can diminish correlation between the variables. The researcher must also assess the factorability of the correlation matrix. The first step is a visual examination of the correlation, identifying those are the statistically significant. Table 4 shows the correlation matrix for the 13 perception of HBAT. In inspections of the correlation matrix reveals that 29 of the 78 correlation 30 7% are significant at the 0.101 level, which provides an adequately basis for proceeding to an empirical examination or adequacy for factor analysis on both an overall basis and for each variable. Tabulating the number of significant correlation per variable, finding a range of 0x15 to 9x17, although no limits are placed on what is too high or low. Variables that have no significant correlation may not be part of any factor, and if a variable, here is the assign the approach of the lateness of the factor analysis, product quality, e-commerce, technical support. Here is the factor x6, x7, x8, and they measured. Here is the correlation significant at 0.1 level 3327. So now bolded value indicate correlation significant at the 0.1 significant level. Overall measurement of sampling adequately 609. Bartlett test of the sparsity 948.9 and significance 0.000. So these are the data. Let's talk about the its results. Has a numbers of correlation. It may be part of several factors. We can note these pattern and see how they are reflected as the analysis proceed. The researcher can assess the overall significance of the correlation matrix with the Bart, uh, Bart, Bartlett test and the factorability on the overall set of the variable and the individual variable using the measurement of sample adequates. We call MSA because factor analysis will always drive factor, and objective is to ensure a base level of statistical correlation within the set of the variables, such as the resulting factor structure has some objective basis. In the example of Bartlett test, find that correlation when taken correctively are significant at the 0.001 level. See the table 4. This test only indicate that represent of non-zero correlation, not pattern of this correlation. The measurement of sampling adequate MSA look not only the correlation but also the pattern between variables. In this situation, the overall MSA value falls in the acceptable range above 0.50 with a value of 0.609. Examination of the value for each variable, however, identify three variables x11, x12 and the variable 17. Then have MSA values under 0.0 because variable 15 has the lower MSA value. It will be omitted in the attempt to obtain a set of variables that can exceed the minimum acceptable MSA level. Recalculating the MSA value, point T and variable 17 still has an individual MSA value below 0.50, so it is also deleted from the analysis, and it would hold note that the point that variable 15 and 17 were the two variables with the lowest and highest numbers significant correlation respectively. Table 5 contains the correlation matrix for the revised set of the variable 15 and 17 deleted along with the measurement of sampling adequately and the Bartlett test value. In the reduction correlation matrix, 20 or the 55 correlation are statistically significant. As with the fully set of variable, the Bartlett test shows that non-zero correlation exists at the significant level of 0.0001. The reduced set of variable collectively meet the necessary threshold of the sampling adequately with the MSA value of 0.653. Each of the variables also exceeded the threshold, that is indicating that the reduced set of variables meet the fundamental requirement for factor analysis. Finally, examining the partial correlation shows only 5 with values greater than 50, variable 6, 11, 7, 12, 8, 14, 9, 18, and 11 and 12, which is another indicator of the strength of the inner alienship among the variable in the reduced set. It is of note the both variable 11 and 18 are involved in two or high partial correlation collectively. These measurements all indicate that the reduced set of the variable is appropriate for factor analysis, and analysis can proceed to the next stages. Let's talk about the component factor analysis stage 4 through the 7. As noted earlier, factor analysis procedure are based on the initial computation of a complete table of intercorrelation among the variables. Correlation matrix. The correlation matrix is then transformed through the estimation of the factor models to obtain the factor matrix containing the factor loading for each variable. One each driven factor, the loading of each variable on the factor are then interpreted, identify the underlying structure of the variable. In this case, perception of but these steps for factor analysis contained in stage 4 around the 7 are examined first for component analysis, then a common factor analysis is performed and comparison made between the two models. Stage 5, driving the factor in assessing the overall fit. Given the correspondent method of extraction will be used first, the next decision is to select the number of components to be retained for the further analysis. As discussed earlier, the researcher should employ a number of different criteria in determining the number of factors to be retained for interpretation, ranging from the more subjective, for example selecting a number of factors applied or specify the percentage of the variance extracted, to the more objective latent root criteria or scale test criteria. Table 6 contains the information regarding the 11 possible factors and their relative explanatory power as expressed by the eigenvalue. In addition, to assess the importance of each component, we also use eigenvalue to assess the selecting the number of factors. Here is the assessing the appropriateness of factor analysis. The revised set of variable x15 and x17 deleted correlations means ras of the sampling adequacy and the partial correlation among the variables. So here is a Bartlett test of the sparsity, that is a 0.6193 and the significance 0.00. Here it is also the same. A result of the extraction of component factor. Component is 1 to 11, total is here, and here is a percentage of the variance. Here is the cumulative percentage. Let's talk about further. The researcher is not bound by preconception as the number of factors that should be retained, but partially reason as a describe multiple measurement per factor indicated the between 3 and 5 factors would be being given at 11 variables to be analyzed. If we play the latent root criteria and the retaining the factor with eigenvalue greater than 1.0, the factor will be retained. Thus screen test, which is shown in figure 9, however indicate that 5 factor may be appropriate when the considering the change of the eigenvalue, that is the identify the L below in the eigenvalue in viewing the eigenvalue for the fifth factor that lower than 0.61. The fifth factor that is lower than 0.61 relative latent known criteria and value 1.0 represent precluded its inclusion. If the eigenvalue had been quite close to 1, then it might be considered for inclusion as well. Then the factor retained represents 79.6%. Variance of the 11 variable deemed sufficiently in term of total variable analysis. More importantly, these results illustrate that the need for multiple decision criteria in deciding the number of correspondent be related. Stage 5, that is a interpreting the factor analysis, that is with four factors of the analyzing research now turns to interpreting the factor. Once factor matrix loading can be calculated, the interpretation, here is the interpretation, here is the eigenvalue, here is a factor. So the 6 to here is a 0.10 screen test for the component analysis. Proceed by examining the unrotated and the rotated factor matrix to significant factor loading and adequately communication. If the deficiencies are found, the specification and the factor is considered. Once the factor are finalized, they can be described based on the significant factor loading characterized each factors. Let's talk about the stage 1, that is the examining the factor matrix of loading to the ortho unrotated factor matrix. Let's talk about the stage first, that is the factor loading. In either the unrotated or rotated factor matrix represent the degree to associate correlation each of the variable with each of the factor. The loading take on a key role in interpretation of the factor, particularly if they are used in way that require characterization as the substantial means analysis. In these instances is to maximize the association of each variable with a single factor many times through the rotation of the factor matrix. The researcher must make a judgment to the adequacy of the solution in this stage and its representation of the structure of the variance and ability to meet the goal of the research. We will first examine the unrotated factor solution and determine whether the use of rotated solution is necessary. Table 7, that is unrotated component analysis factor matrix. To begin the analysis, explain the number of included. The table 5 column of the number are shown. The first 4 are factors. So first 4 are factors 1, 2, 3 and 4. These are the factors. The fifth column provides a summary of statistical dealing, how well each variable explained in bottom to each column. So fifth column is provide the summary of the factors. Is the column sum of the square of the factor analysis eigenvalue and indicate that the relative importance of each factors in accounting for the variance associated with the set of variable. Note that we submit square for the force, that is 0.4 to 27, 2.511 and 2.551 and 1.691. Here is a 1.87. These are the respectively. As expected, the factor solution extracted across the order to importance with the factor according to 1 and most variance factor 2 slightly less than the through the all 11 factors. All the right hand side 11 factors, these are 8.756. We represent the total of the 4 eigenvalue, that is 3.27 after adding the values 2.55, and these are the total eigenvalue represent the among of the variance extracted by the factor solution, that is the product quality, e-commerce, technical support, compliant resources, advertisement, product line, sales enforcement. These are the factors, and here is our commonalities. So trace 11.0 sum of eigenvalues. Total value amount of variable explained by either the single factor or the overall solution can be compared to the total validation of set of variable and represent the trace of the 4 matrix. The trace is total variance of the explained and the equal to of sum of the eigenvalue use of the variable set. In component analysis, the trace is equal to the number of variable because each of the variable possible eigenvalue of 1.0 by adding the percentage of trace of each of factor individually, total eigenvalue of the factor by the trace. We obtain the total percentage of trace extracted for the factor solution. This total is used to be indexed and determine how well a particular factor solution encountered for what are variables together represent. If the variable are all very different from another in index will lower if the variable fall in under the more highly redundant of the related group, and if the extracted factor amount of all the group is to will be approach 100%. The percentage of the trace explained by each of four factors, that is a 31.15%, and these are the four factors respectively, are shows as the last row value of table 7. The represent the trace obtain the value. So here is the explanation of the value. Therefore the index of the solution highly variable are the fact and highly related. Another step 2 I will talk about in further video. I will call it, that video will be the 5 video of the factor analysis, where I will talk about the identify the significant loading in the unit tendency factor matrix.